Okay, in this lesson we're going to look at how to solve problems using acute triangles. So it's kind of a summary of what we've been looking at in this chapter so far, which is the sine law and the cosine law. So before we do that, we're going to have to recall when to use the sine law or the cosine law and determine when those are useful. For the sine law, in order to use the sine law, you must know the measure of an angle and its opposite side. For the cosine law, there's two cases where you can use a cosine law. You must know either of the next two cases, either two sides and the contained angle, or all three sides. So if we look at these 6 examples, we just have to determine how to solve. So for each triangle, determine if you would use the sine cosine law or neither to calculate the indicated angle, measure of side length. And it says also give the formula that would be used to solve for the indicated angle or side. What we're going to do is just state if it's going to be the sine law, the cosine law, or neither in this particular case. So if we look at example number 1, if we were trying to solve for the question mark side, what you may notice is we've got these two sides and what I'm going to call the contained angle. So if we have two sides and a contained angle, that's this case right here, two sides and a contained angle, that is the cosine law. So in order to solve for this problem, we would be using the cosine law. In the next problem, to solve for that question mark, what we have in this particular case at the moment is an angle and its opposite side, and we are given a side and we're asked to solve for its opposite angle. So in this particular case, since we know that is 90 degrees opposite 15 centimeters and 12 centimeters opposite the question mark angle, that is, you must know the measure of an angle and its opposite side. So in this particular case, this would be using the sine law. Our next problem. In this next problem, what it says is we are given an angle and its opposite side. However, we are not given the side that's opposite this angle, so we don't know this side either. So that is a little bit of a question mark. At this particular moment, it looks like we can't solve for anything. However, what you may notice is what we could do first of all is solve using the sine law for this blue angle first. So if I point here, I would say this would be our first step. We could use the sine law to solve for that. And once we know that angle, we could use angles of a triangle are equal to 180 because we would have 2 out of 3 triangles. So where would we start? We'd start with the sine law. All right, next one. In this particular case, you'll look and see that we have 2 angles. We aren't given any other information. We could find the third angle, so this third angle would be, I believe, 67 degrees. However, what you'll find out is that's not helpful because in all cases, whether it's cosine law or sine law, you need to have the length of a side. So in this particular case, we would use neither. It's impossible to solve this particular problem. In the next example, we have 2 angles and a contained side, and there's no definition about how that would work. So in this particular case, we're trying to solve for that question mark. We do have its opposite angle, but we don't have the opposite angle of 18. But, however, we could find that out. Because we have the 40-degree angle, we could find out that the missing angle would be 52 degrees. And that would be helpful because at that point in time, we would have an angle on its opposite side. And then we could use the green opposites and the orange opposites in the sine law. So in some cases, you may have to solve for something first. And the last question, in this particular question, we are given the lengths of all 3 sides. In this particular case, we know that that would be the cosine law because the cosine law is used when we know all 3 sides of a triangle and we're asked to find an angle. All right, we're going to look at one problem in this particular lesson. In the following lesson, we'll look at the next 2 problems. So just how do we solve problems? Essentially, you want to have an open mind and you like to just find out anything that you know, even if you don't know if it's headed in the right direction. So in this particular case, we're looking at the tallest freestanding totem pole in Beacon Hill Park in British Columbia. So essentially what this gentleman wants to do, his name is Manuel, he wants to determine the height of the totem pole. So here's what he did. He walked along the shadow of the totem pole and counted 42 paces. So if you want to look at this picture here, he basically walked from the base of the totem pole up to here and counted 42 paces, so roughly 42 meters. He estimated each pace was 1 meter. He estimated the angle of elevation of the sun was about 40 degrees. So from horizontal, the sun is about 40 degrees in the sky. And finally, he observed that the shadow ran uphill, so he estimated this angle of elevation here that he walked up a hill at an angle of elevation of 5 degrees. And the question says, how can Manuel determine the height of the totem pole to the nearest meter? So we're going to solve for the height of the totem pole, even though we're just essentially estimating, which will be kind of cool. In this particular question, just start somewhere. So here's the diagram. What you might want to notice is in this triangle, so one place you can always start is in a triangle. You know that the angles always add up to 180 degrees. If we have a 5-degree angle down here and a 40-degree angle down here, then we know that this angle right here would be, it's a little bit hard to point at, but it would be 180 minus 40 minus 5, and that would be 135 degrees. Okay? So maybe if I erase this, this little angle here is 135 degrees. What we also know is that angles on a line, for example, add up to 180 degrees. So if we have this line here, then this angle here has to add up to 180 with 135. So that angle there would be 180 minus 135, and that's 45 degrees. So let me erase that and kind of just indicate that on the triangle here. This would be 45 degrees. So it's often useful to just figure out angles. As we have this right angle right here, so if this is a right angle, let me also indicate in another red here that this must also be a right angle. And what you might notice is that we've got a 5-degree angle within that right angle. So this angle right here, there's a lot of just pointing going on. That angle right there has to be the 90-degree angle minus 5 degrees, so that would be 85 degrees. And finally, if I'd like to, maybe I'll use black here. Finally, if I'd like to, it might not be useful, or it might be useful, is finding the angle that's at the top of this triangle here. And what you'll notice is in this triangle right here, we now have a 45-degree angle and an 85-degree angle. So this angle up here has to be 180 minus 45 minus 85, and that would be equivalent to 50 degrees. I believe, yes. All right. So essentially all we've done up to this point is just angles of a triangle equal 180 degrees, and sum of angles on a line equals 180 degrees, and we found out all the angles that we need. We haven't even done any particular sine law or cosine law stuff, but this might be useful. Let's first of all, if we look at this triangle that includes the totem pole, what you might recognize is that we have a few things. In fact, we've got a lot of things, but if we look at the side that we're given 42 meters. We know that 42 meters is opposite the 50 degrees. So that might indicate maybe the sine law is going to be of use here. What we'll also notice is that this 45-degree angle is opposite the height of the totem pole. So in this particular case, what we can do actually is use the sine law with those. So the sine law is set up like this. For solving for a side length, we always put that in the numerator. So h over sine of its opposite angle, sine 45, is equivalent to another side length, which in this case is 42, and that's over sine of its opposite angle, sine 50. We've set up the sine law. We're getting very close to solving. Our one step is to multiply both sides by sine 45 because we're solving. So these cancel out, and we're left with h being equal to this product and quotient. So I would use multiple steps on your calculator. So again, when you turn your calculator on, make sure it's in degree mode. If it's not, you will get incorrect answers because we're dealing in degrees. And then you just want to calculate using the equals button as often as possible. So 42 divided by sine 50. You may want to pause this and try it on your own and then check to see if you get the answer right. So 42 divided by sine 50 is equal to 54.827. So that's this proportion here. Now we need to multiply by the sine of 45. And we get an answer of 38.768, and this says to the nearest meter. So the nearest meter, it rounded up to 39 meters. So the totem pole is roughly 39 meters tall.